Good morning. Today our new class is open loop and closed loop configuration. Open loop configuration and closed loop configuration. Okay. Next, recap of this presentation. In previous class, we discussed about pinout diagram of IC 741 op amp. Pinout diagram of IC 741 operational amplifier. And next, characteristics of ideal and practical op amp. Characteristics of ideal and practical op amp. So these two topics are completed in previous class. Okay. And next objectives of this presentation. On completion of this period, you would be able to understand open loop and closed loop configuration. Open loop configuration and closed loop configuration in this topic, and also limitations of open loop configuration. Limitations of open loop configuration and summary. So these two topics are discussing one by one now. Okay. So first of all, the first topic is open loop and closed loop configuration. Open loop and closed loop configuration. So see this figure. This is the figure of below figure. See this below figure. This is the figure of open loop differential amplifier. Open loop differential amplifier. Okay. So first of all, open loop configuration of operational amplifier. An operational amplifier is configured either open loop or closed loop. An operational amplifier is configured either open loop or closed loop. Okay. So in open loop configuration, no connection exists between input and output terminals of operational amplifier. Okay. First of all, operational amplifier is configured either open loop or closed loop. So in case of open loop configuration, there is no connection exists between input and output terminals of operational amplifier. Okay. Next, the operational amplifier. What are the functions of operational amplifiers? The functions of operational amplifiers as a very high gain amplifier. So what is the main function of operational amplifier is? So the functioning of operational amplifier is a very high gain amplifier. Very high gain amplifier. Let us consider an open loop differential amplifier. This is the figure. See this figure. In this figure, the input voltages. Here how many voltages? 2 input voltages. Okay. The input voltages are represented by V in 1 and V in 2. So V in means input. Here 2 voltages are used. That's why V in 1 and V in 2. So what about output voltage? V0 is the output voltage. Okay. So write down the equation. The output voltage V0 is equal. So gain A of V in 1 minus V in 2, because it is a differential amplifier. That's why we can apply 2 inputs. Then the output is difference of these 2 inputs. Okay. Here, so then the output voltage V0 is equal A of V in 1 minus V in 2. So in this equation where A is the large signal voltage gain. A is the large signal voltage gain. In this configuration, in this open loop configuration, a small value of input difference voltage can be applied. In this configuration, in this open loop configuration, a small value of input difference voltage can be applied even for voltage levels slightly greater than 0. Even for voltage levels slightly greater than 0. The output is driven into saturation. Okay. So I repeat this point again. So where output voltage V0 is equal A of V in 1 minus V in 2. In this equation where A is the large signal voltage gain. So in this open loop configuration, a small value of input difference voltage can be applied. even for voltage levels slightly greater than 0. Even for voltage levels slightly greater than 0, the output is driven into saturation. So thus, when operated in the open loop configuration, the output of op amp is either negative or positive saturation levels. Thus, when operated in the open loop configuration, the output of the op amp is either negative or positive saturation levels. This prevents the open loop configurations of op amps from being used in linear applications. Okay, this prevents the open loop configurations of op amps from being used in linear applications. The non-linear applications of closed loop configuration are square wave generators, astable multivibrators, comparators, etc. Okay, I repeat once again this point also. Open loop configuration. So an operational amplifier is configured either open loop or closed loop. So if in case it is configured in open loop, there is no connection exists between input and output terminals of operational amplifiers. See this figure, observe these connections. So there is no connection between input and output. So the operational amplifier functions as a very high gain amplifier. So let us consider an open loop differential amplifier figure. So in this figure, the input voltages are represented by V in 1 and V in 2. So the output voltage V0 is given by the formula V0 is equal A of V in 1 minus V in 2. Okay, now in this equation, where A is the large signal voltage gain, in this configuration, a small value of input difference voltage can be applied even for voltage level slightly greater than 0. The output is driven into saturation. Thus, when operated in the open loop configuration, the output of the operational amplifier is either negative or positive saturation levels. This prevents the open loop configurations of the open loop configurations of operational amplifiers from being used in linear applications. Okay. So next, the non-linear applications of closed loop configuration are square wave generator, astable multivibrator, comparator, etc. Okay, so this is nothing but open loop configuration of operational amplifier. Okay, next, closed loop configuration of operational amplifier. Observe this figure below. So this is the figure of closed loop differential amplifier. In closed loop configuration, see this figure. In this figure, some fraction of output signal is fed back to the input of operational amplifier. The gain of the op amp can be controlled. If feedback is introduced in the circuit. The gain of the op amp can be controlled if feedback is introduced in the circuit. Okay. So next, continuation. An output signal. Here output signal is V0. An output signal is fed back to the input either directly or via another network. An output signal is fed back to the input either directly or via another network. Okay. Let us consider a non-inverting closed loop op amp as shown in this figure. Here input signal voltage Vin is applied at non-inverting terminal and a fraction of output voltage is applied at the inverting terminal via resistors R1 and RF. Okay, let us consider a non-inverting closed loop operational amplifier. This is the figure shown in figure. So in this figure, input signal voltage Vin is applied, input signal voltage Vin is applied at non inverting terminal, and fraction of output is fraction of output voltage is applied at inverting terminal via resistors R1 and RF. Okay, this is the closed loop differential amplifier figure. In this figure, the closed loop voltage gain of the circuit is the closed loop voltage gain of the circuit is given by so voltage gain is capital A. So CL is closed loop voltage gain is denoted by ACL. Closed loop voltage gain is denoted by ACL. ACL is equal 1 plus RF by R1. ACL is equal 1 plus RF by R1. This is nothing but closed loop configuration of operational amplifier. Okay, so open loop configuration and closed loop configuration of operational amplifier is completed. And next topic is limitations of open loop configuration. So the first limitation is nothing but clipping of output waveforms occurs when the output voltage exceeds the saturation levels, either positive saturation or negative saturation. I repeat once again this point. Clipping of output waveforms occurs when the output voltage exceeds the saturation levels. Okay. Next, the second limitation of open loop configuration is nothing but smaller signals of the order or microvolt or less having very low frequency. Smaller signals of the order or microvolts or less having very low frequency can be amplified accurately without distortion. I repeat once again this point. Smaller signals of the order or microvolts or less having very low frequency can be amplified accurately without distortion. Okay. And next, third limitation of open loop configuration is nothing but signals of such low magnitude are very susceptible to noise and almost impossible to obtain. The third limitation of open loop configuration is nothing but signals of such low magnitude are very susceptible to noise and almost impossible to obtain. Signals of such low magnitude are very susceptible to noise and almost impossible to obtain. Okay. And next, fourth limitation of open loop configuration is nothing but the open loop gain of op amp is not a constant. Open loop gain is nothing but capital A. So it is not a constant and varies with changing temperature and power supply. If temperature changes, then open loop gain also changes. If power supply changes, then open loop gain also changes. Okay, so open loop gain is not a constant. It depends on changing temperature and power supply variations. Okay. And next limitation of open loop configuration is nothing but the bandwidth of the most open loop op amps is negligibly small, up to 5 Hz. The bandwidth of the most open loop operational amplifiers is negligibly small, up to 5 Hz. Okay, so bandwidth is up to 5 Hz is negligible bandwidth in open loop operational amplifiers. Okay, and next limitation of open loop configuration of operational amplifier is nothing but due to negligibly smaller bandwidth, this configuration is not suitable for AC applications. So due to negligibly smaller bandwidths, that is, it is negligible up to 5 Hz of bandwidth. this configuration, open loop configuration, is not suitable for AC applications. Okay, so I repeat these 2 points once again. If bandwidth is very small, that is up to 5 Hz, okay, so this can be neglected. This can be neglected in open loop operational amplifiers. So due to negligibly smaller bandwidth, this configuration is not suitable for AC applications. Okay, and next, the last limitation of open loop configuration is nothing but these configurations, these open loop configurations are not used in linear applications. These configurations are not used in linear applications. These are different limitations of open loop configuration. I repeat once again. Limitations of open loop configuration. Clipping of output waveforms occurs when output voltage exceeds the saturation levels. If output voltage exceeds the saturation levels, then some of the output waveform is clip off. Okay, so the smaller signals of order or microvolts or less, having very low frequency, okay, so can be amplified accurately without distortion. So by using open loop configuration, very low frequency signals are amplified without accurately amplified without distortion. Okay, next, signals of such low magnitude are very susceptible to noise and almost impossible to obtain. And also, the open loop gain of operational amplifier is not constant. It depends on temperature changes and power supply variations. Okay, next, the bandwidth of the most open loop operational amplifiers is negligibly small, up to 5 Hz. Next, due to negligibly smaller bandwidth, this configuration is not suitable for AC applications. These configurations are not used in linear applications. Okay, these are different limitations of open loop configuration. These are the different limitations of open loop configuration. Okay, so open loop and closed loop configuration of operational amplifier is completed, and also limitations of open loop configuration are also completed. Okay, next, summary of this presentation. We have seen open loop and closed loop configuration and limitations of open loop configuration. Okay, these two topics are completed. And next, frequently asked questions may be asked. Frequently asked questions may be asked. The first question is, what are the limitations of open loop configuration of operational amplifier? What are the limitations of open loop configuration of operational amplifier? And another question may be asked in this today topic. Draw the circuit diagram of open loop differential amplifier. Draw the circuit diagram of open loop differential amplifier. So, and another question may also be asked as, draw the circuit diagram of closed loop differential amplifier. Draw the circuit diagram of closed loop differential amplifier. And one more question may also be asked in today's topic is, draw the open loop and closed loop configuration figures. Draw the figures of open loop and closed loop configuration of operational amplifier. And another question may also be asked in today's topic is, explain briefly about open loop and closed loop configuration, and also write any 3 limitations of open loop configuration of operational amplifier. Okay, so different type of questions may be asked in today topics. Okay, so it can also be asked, maybe define open loop configuration, define open loop configuration of operational amplifiers, and also define closed loop configuration of operational amplifier. So different type of questions may be asked in today topics. Okay, today topics are very important topics. Prepare well. Okay, any doubts? Very important topics. Any doubts? Okay, thank you.